okay? The two processes we have is the combustion of graphite right? And the combustion of diamonds. Now before we've said that combustion is always adding oxygen to get carbon dioxide and water. Why don't I have water this time? I didn't burn a hydrocarbon, right? It was just carbon that I was burning other than a hydrocarbon. Okay, so what am I going to do with the first equation? For the first one, for this one? Do I need to? No, it's good, right? Okay, and I didn't copy the delta H over there, so let's get it now. It was a negative 393.5. Okay, how about the second equation? That one I do need to flip, right? Okay, so this time I have carbon dioxide goes to oxygen plus diamond. So since we flipped it around, it's now a positive 395.4, right? I had to change the sign. So carbon dioxide cancels, oxygen cancels, leaving with graphite going to diamond, right? And our delta H positive this time, right? Okay, so we've done a couple of the easier ones. Let's just get a little bit more complicated. We're going to have 3 intermediate steps. This is practice exercise 1 on page 189. Okay, our overall reaction is carbon plus water goes to carbon monoxide plus hydrogen, right? Okay, that's the overall process we want. We have, and let me know if I copy any of these up wrong. Carbon plus oxygen goes to carbon dioxide. Okay, did I get them all up okay? I think we're good, right? Okay, so what do I need to do first? Yeah, if they weren't balanced, we would need to double check that they're balanced. I think we're okay on all of them, aren't we? Okay, now
To
what?
make sure if you need to change any of them,
Say that again?
you need to see if you need to change any of them, like
Like we need to flip them around.
if you need to flip them.
Okay, so we need to decide how we want to use them. So how do we want to use the first one? Yeah, let's keep it as is. Okay, is there anyone having any questions on how we decide what to do with it?
I have a question on what exactly we're looking for.
Okay, there's two ways that you can think of it. You can either look at this and say, what do I have in here that matches up here? The only thing I have is the carbon, and the carbon's on a reactant side
I
here.
understand that, but like what exactly is the H? Like the
We're trying to
H?
get the overall process by combining the intermediate steps
The overall process
of the first reaction.
Of the first reaction. Oh,
Yeah.
okay.
Does that answer your question? Kinda? Yeah, it's kinda like, we're here, we want to get to here, but we don't know how to get to there. But we do know how to get from here to here, here to here, and here to here. So we're gonna go around this way to get over there,
Okay.
okay? Does that kinda help, maybe? Yeah.
So now for the second one, would you double the delta H, or would you cut it in half?
What do you think? Do you see where he's looking at the second one? His problem is the 2 here, because there's no 2 there. So do we want to divide by 2, or do we want to multiply by 2?
Divide by 2.
Divide by 2. Because if we multiplied by 2, we'd end up with 4, 2, and 4 as coefficients, right?
Wouldn't
That's
help
not going
us.
to help, okay? So we want to divide by 2. So let's say that we have this carbon monoxide plus 1/2 oxygen. Don't forget that 1/2 oxygen. When we divide, we have to divide everything by 2, right? Not just the ones that already had a coefficient of 2. Okay, so this is going to be 1/2 of our delta H. So it's a negative 566.0 kilojoules divided by 2. Okay? How about the third equation? We want to flip that one. Do we want to divide or multiply or anything?
Divide by 2.
We need to flip it and divide, right? So we're going to have water goes to hydrogen plus 1/2 oxygen. Okay, so we flipped it around and divided by 2, right? So that means we're going to have negative 1/2 times our delta H3. Okay, so we have a positive 483.6 kilojoules now, divided by 2, right? Okay, so let's look at this. What can cancel?
The half oxygens.
Okay, the 1/2 oxygen here and 1/2 oxygen here can cancel. What else? Do we have anything else that can cancel? No, I don't think so. Okay. Did I write everything correctly? Because we're not,
Don't you need to reverse the second one as well?
okay, this one,
So what the CO2 is canceled?
yeah, we divided by 2, we did not reverse it, okay? CO2s won't cancel by not reversing. This is where the bookkeeping comes in, right? Because from what we have right here, from what we've canceled, we have carbon plus oxygen plus carbon monoxide plus water. That's too much stuff on the reactant side, right? So, is it the first one we want to flip? Okay, half oxygens won't cancel, but let's see what else happens. Okay, if we reverse it and divide by 2, we end up with CO2 goes to CO plus 1/2 oxygen, okay? And I'm gonna fix this because we can't cancel it now, right? Okay, what has to happen here?
That's positive.
It's now positive, right? Still divided by 2, but it's now positive. Okay, so let's look at our oxygens. I have a 1/2 oxygen here and a 1/2 oxygen here. If I add those together, don't I end up with 1 oxygen? Which is what I have here. So the half oxygens don't cancel anymore, but the 1 oxygen did. Does that make sense?
Yes.
We good? All right, what else will cancel?
CO2s.
CO2. Okay, so does that look better now? We're gonna end up with carbon plus water goes to carbon monoxide plus hydrogen. Is that what we wanted over there? Yeah, so we're good, right? So now we can add these guys together. So the delta H for the overall process is a positive 131.3 kilojoules. And that's what we were trying to get, is the overall process. Okay? Okay, going back to what I was saying just a minute ago, and we'll finish up on that. There's different ways that you can think about this.